Green. All right.
Okay, it's recording.
All right.
Okay,
Sorry about
I
that.
don't know as I'll repeat all of that, but in any event, I'm definitely a physical realist, so I believe in the existence of things like atoms and light independently of our experiences of them. And I also definitely believe in the existence of fields. And I think that particles have fields. And my presentation today is on a model of the electric field, which I think is actually the most basic. Some people would say gravity, but I think it's actually the electric field that's the most basic. And it's also the one that works out best for my model. But if you say that you're not dealing with experiences, then you have to have some other basic thing exist. And the best thing I've ever been able to work out here is, or known as pre-Socratic various entities. The only one they really talked about was solids, but I find the liquid state works best. So my next slide is on that, the ideal liquid state. Let's see, can you move the slide, Harry? Or can I? Let me see if it works.
It was working a minute ago.
Okay, so here's the concept of an ideal liquid. The volume remains a constant, that is, it's incompressible. It changes its shape when placed under pressure, and it can be divided into parts when pulled in different directions. I distinguish, and this is a little bit arbitrary and ad hoc, but this is the only thing I've ever been able to do that makes things work. I distinguish between positive ideal liquids, which correspond to positive electric charges, and negative ideal liquids, which correspond to negative electric charges. And I conceive of them as flowing into each other. And what I should have added there is the rate of flow I take to be the speed of light. And I've also worked out a model of light off of this, but I'm not going to be talking about that today. Okay, maybe we can have the next slide. Okay, this is my concept of a field, and it's, as far as I can see, it's mathematically equivalent with the traditional physics concept, but it differs on where I do a summation. So I claim that each charged particle has its own field in a separate three-dimensional parallel subspace. And so each particle has its own field, and then you talk about the contributions from the different fields, which would be a resultant force involving a vector summation of all of the fields at a given location. And then I give a model of what I call thin shells. So I say the fields are comprised of these thin shells, which in turn are comprised of the ideal liquids. See, I think the next shell talks about some properties of the thin shells. Move on to the
question, Jim. Yeah, what is a separate three-dimensional parallel subspace? What is that?
Okay, that's actually a good question. There are lots of details here. The closest I can find here for someone who talks in similar manners is if you can't come across the multiple worlds interpretation of quantum mechanics, Hugh Everett's version. And they tend to have an infinite number of these parallel universes. I at least keep a finite number, but it's a big number, like corresponding to the number of charged particles in the universe. Best estimate I've seen there is like 10 to the 80th. So it's a large number, but it's finite.
What is the rationale to even go there?
Just to make this model work. I think you have to see some of the more details, and then we can come back to that. I think it almost would help to get to the end of the presentation and then go back to slides for people who have questions. I'll admit a lot of this is kind of arbitrary. You can't do this a priori independently of experience. You just have to work around with models and find one that works. You sure don't gain certainty here. But it's the best I've been able to come up with. Okay, let's try the next slide, maybe. Okay, structure of the thin shells. So each particle has its own field in a separate three-dimensional parallel subspace. These fields consist of a series of nested thin shells centered on their host charged particles. Thin shells are assumed to possess equal volumes. And that's actually a key point, because if they have equal volumes, then from the formula for the area of the surface of a sphere, that goes as 4 pi r squared. And if the volumes are equal, then their thickness is 1 over r squared. So you get a nice motivation for an inverse square law off of this. And then I say that 4-dimensional bound electrons intersect thin shells so as to be affected by the force fields from each of them. And then you have a summation of these various forces. And that's where, as far as I can see, it's mathematically equivalent with the traditional physics conception.
Let me stop you here, Bob. By
Yeah, sure.
thin shell, you mean the volume between two spherical surfaces.
That's right. So they have slightly different overall radii and the thickness between them. That's correct.
Okay.
Okay. Yeah, let's move on to the. Okay, this is the way that I see them as coming into existence. The beginning, it's like a sphere, say with negative ideal liquid, maybe an electron. It pulls in ideal liquids of some sort from the surrounding area, which makes a surplus of the negative in those surrounding areas. And this gets a little bit complicated, but basically what I have is an oscillation between the ideal liquids going back and forth between, and as time passes, you get more and more thin shells, an indefinite number over time. And again, I identify those thin shells with the electric field. Okay, we may want to come back to that, but let's move on to the next slide. Okay, this is how electrical attraction would work. So you have here a charged source particle, positively charged. So here, the positive ideal liquid would be on the outside and would flow into like the negatively charged particle. So the two are drawn together. And if the two are drawn together, that will result in electrical attraction. And for the inverse square law, as far as the strength goes, since the width of these thin shells varies at an inverse square rate, you can come up with the Coulomb force off of this. That's for electrical attraction. The next slide is for electrical repulsion. So here the charged particle is on the inside, so it's pulled outwards. And here for repulsion, the two particles, they would have the same charge. So it's pulled in by the inner side of the thin shell, and that's what makes it go away from them. And again, at an inverse square rate, so that would be electrical repulsion. Let's see the next slide. Cosmological role of electric fields. Electric fields are conceived as being the most basic of the physical fields, in the sense that other fields are conceived of as being comprised of properties of them. Electric fields are conceived as extending throughout physical space. However, the effects of electric fields usually cancel out to the extent that macroscopic objects tend to be electrically neutral. And then if some astronomical bodies are not electrically neutral, there may be other observable effects. I mentioned Birkeland currents here. I kind of got that one from Harvey Scribner, and I don't know a lot about them. And he seems to think that the universe is full of these. I really don't have a strong opinion there. All I'm saying is that if you have electrically non-neutral bodies in the universe outside of the Earth, there may be observable effects from them. But again, I don't have a strong opinion on this. Other people know more about it than I. Let's see, maybe the next slide.
I think this is the end. Oh.
No. Speculative extension to other forces. I might say kind of first that I think my model works best for the electric field. So I'm much less confident about these extensions, but if you want to make a model work throughout, then you have to push it. And these are moves I've found for trying to push it. And if anyone would like to help me on getting this better, I definitely would appreciate it. But first, for magnetism, I don't think the magnetic field is different from the electric field, but magnetic fields seem to involve moving electric charges. And hence, in the thin shell model, they may correspond to vortices in the shells. That needs work. There is a tie-in, like as far as magnetic statics is concerned, with spin. And I have worked out spin to some extent. And again, I do that in terms of vortices. So again, the question is how far to push it. Gravity, I wish I had a better model of gravity. But you might note, even for the initial sphere, that the inner portion is radius-wise longer than the outer portion if there are equal volumes. So you get a difference between those two. So I say gravity may involve a remnant property of thin shells, possibly involving a difference among the widths of the sides of adjacent thin shells. And if you work out the math of this, it actually goes to an inverse radius to the minus 5 rate. And obviously gravity goes at an inverse square rate, in which case a compensating factor would be necessary here. I've tried to work with models. I've never came up with one that was all that satisfactory. But finally, nuclear forces, I say, may not possess an independent existence, since if there is no electrical repulsion among nucleons, and if there are no thin shells between them, then there may be no need for a separate nuclear force to hold them together. In other words, if there's no electrical repulsion because there are no thin shells there, and of course electrical repulsion would be an extremely strong force, in which case you would need a nuclear force to hold things together. But if you don't have the electrical repulsion, maybe it's just the initial series of thin shells holding the nucleus together. And there, for the first shells, my move is trying to identify those with electron orbitals, which again, I try to construe realistically. Okay, and then let's see, here he wanted me to also have a slide on some links with cosmology, and here's what I came up with. The model fits in better, I think, with a finite model of the universe than an infinite model. If you start making things infinite, the width of the shells is going to become infinitesimal and issues like those. So I think it does work in better with a finite model, based both in terms of space and also in terms of time. There's a link with emission theories of light. As soon as I came up with this thin shell model and where you had all these different parallel fields, I developed an interest in the ballistic theories because each particle is going to have its own wave trains of light. I use a model which I call wave particle unity. I actually got this idea from Hussein Yilmaz. So the speed of light depends upon the speed of the source. But this is not Ritz's ballistic model. For Ritz, he thought of the photon as being like a bullet, and he had a ballistic theory, and it would have a completely independent trajectory once it left the source particle. Whereas since I equate it with basically things occurring within the thin shells, which move with the host particle, with the wave train and oscillations within the wave train, I identify light. I have a whole chapter of my ebook on this subject, but I basically defend a version of the emission theory. And then finally, since the theory rejects special relativity, it also rejects general relativity, in which case alternative explanations need to be given for such phenomena as gravitational lensing. I was friends for a long time. He died a few years ago, but with Ed Dowdy, and he definitely did not believe in gravitational lensing, and he held a version of some material published defending this. So those were the links with cosmology, which I came up with. Okay, well, that in any event is the end of the presentation, and I would welcome questions. How satisfactorily I'll be able to answer everything, I don't know. This is a work in process. It's obviously speculative, but it's something I was able to make at least a fair amount of progress with, and certainly I would appreciate like any collaborative work anyone wants to put into this. There's only so much I can do by myself, so I definitely welcome like input from others, and certainly it helps if it's constructive. Just saying it doesn't make any sense or something actually isn't helpful, but anything constructive it can be helpful.
Well, right there, are you talking about protons and electrons, for instance?
Excuse me, I'm having trouble hearing you.
Right there on the screen, were you talking about protons and electrons, or possibly something else? Positively charged.
I put this up here because I find what's interesting about Bob's idea is it explains the repulsion and attraction, which I think is sort of not really, is kind of just like well, there's no explanation for it really in the traditional physics. But you had a question.
That's what seems to work out most naturally here. So you need something positively charged, but it could be like an atom that's lost an electron, an ion, positive ion.
Yeah. Well, I didn't quite understand what the function of thin shells.
Thin shells, okay. Yeah, the thin shells, they basically surround each particle. They are three-dimensional. To make this work, I've had to have my particles be four-dimensional, and they each have an equal volume. And if you have an equal volume, then the width across varies in an inverse square rate. And also, just to make things work, and again, I'll be the first to admit it can sound a little bit strange, I have the outer part and the inner part of the shells, the opposite ideal liquids, and have them flow together into a parallel subspace and then flow back. So they oscillate back and forth, which I'll admit sounds kind of counterintuitive, but it's the only move I've been able to come up with to make things work. And of course, none of this is immediately experienced or testable immediately. It may have indirect testable consequences, but it's not immediately testable.
So you're competing with string theory.
Maybe. I'm not a big fan of string theory. I think they're like strings. I think they think of them as being one-dimensional, whereas my thin shells, they're three-dimensional.
I meant in terms of being untestable.
You may have a point there also. As I'm saying, I think things can be indirectly testable. Actually, I had some of my ideas on light. Friends with this physicist at the University of Maryland, Baltimore County, Yan Hao Shi, And he does like entanglement experiments in the laboratory. I'm actually a co-author of one of his papers. And he was going to do it there, but he had troubles with his equipment. They actually eventually did it in China just a couple of years ago, but the results did not at least immediately confirm my prediction. But that would be an example of trying to test some of this. I think there may be other ways to maybe test things. One thing I've thought of, and I know Harry has an interest in some of this, is like with like primitive like reference frames, in particular as far as rotations are concerned. And maybe if you like did some experiments on testing like primitive rotation rates, maybe in outer space and other bodies, and see whether the same primitive rate is there. I think that might be something interesting to do. Another one maybe with magnetism. I had some correspondence of a French guy, maybe if you've heard of him, Jean de Clement, and he thought maybe there was a way to test between different competing theories of magnetism, in particular maybe with accounts under relativity of it being due to a Lorentz contraction. So he at least suggested a possible experiment there. So yeah, I think there may be ways to make predictions off of this model and perform experiments. So I'm definitely not trying to make something that's not testable. To me, you just first you have to get something consistent with known results. And then once you've got it consistent, try to make other predictions and see what happens. I don't have anything really overwhelming at the moment to tell you about.
Okay. Did you have any more questions, Jerry?
Well, I had some questions throughout the slides. I don't quite remember them. I have to see. I have to see them again.
I'm sure you got plenty of questions.
Volume remains constant in a liquid. It's incompressible though. Is it possible for liquids to compress, like such as a dam or like a very deep ocean, where the density stays the same except the volume compresses?
Well,
I don't really know.
Yeah, I think the model works out best when it's completely incompressible. That's how you get the inverse square rate.
Yeah,
again, it's an ideal liquid. I'm not talking about any actual liquids here. It's an ideal liquid.
I want to point out that the idea that electricity is incompressible fluid is kind of goes back to the beginnings of 17. I'm not sure exactly where it originated before Maxwell. And
yeah, not everything I say is completely novel. Yeah, I've run across that also, Harry.
What is an ideal liquid?
It's, I mean, you can talk about ideal solids, which of course can't change shape. Ideal liquids, just think of properties of the liquid state, but not in terms of any actual liquids like water, for example. But if you put them under pressure, something moves, so they change shape when under pressure. So like a water drop, for example, you can pull it into different parts. So an ideal liquid you can pull into parts.
Is an ideal liquid theoretical, or does it exist somewhere?
Here's what I take this model sufficiently seriously that I try to think of these things as actually existing. But you sure don't gain certainty there.
Okay. Could you try the next slide, please?
You want to go down?
Yeah, please. Well, okay, you accept the many worlds theory, I guess.
I want to be real careful there. I say it has some properties in common with many worlds, but the traditional one, I think you ended up like a higher order infinity of worlds and things like that. I have the number of these subspaces be finite. And there's one for each charged particle. The best estimates I've seen for the number of charged particles in the universe is something like 10 to the 80th, which is a big number, but it's a finite number. But some of the people of many worlds do talk about having parallel universes. So it has that much in common that I talk about parallel spaces.
So the many worlds interpretation, I've never really heard specifically, but I think it's an explanation for the wave function collapse with the double slit experiment.
Except it doesn't collapse for them. The extent, and I do have a chapter on this on quantum theory. My opinion is like for photons, they're spread out across these thin shells until absorption occurs, and I hold absorption is what collapses wave packets. You might note for absorption, I'm not bringing subjectivity into there. I think absorption is a physical process. It can be non-local since something may be spread out over a huge distance and occurs during a very short period of time. Something like 10 to the minus 8 seconds is the best estimate I've seen for like the absorption process.
What are the idea that observation collapses a wave function?
I've definitely come across that way. Von Neumann talked that way. I don't hold it. I believe in a conscious mind. I think there is some connection with the brain that I don't completely understand. But I think it's like in the retina of the eye with the pigments and the rods and cones, they're very strong absorbers. So that's where I think like you have a collapse, or like with a camera.
Bob, you need to keep talking directly into the microphone when you.
Okay, yeah. I was just giving examples of where you have absorption, or like with photodetectors. They have a substance that's a strong absorber, and then it gets amplified, the signal. So I think it's absorption. But you can change the direction of light without absorption. You can have elastic scattering, for example, which I think happens all over the place. So like with my model of light, say with a mirror or wherever light interacts with something, if it's not absorbed, then like you have new sources. So I don't think of light as being like a tiny particle. You have instead like what I call wave particle unity after Yilmaz. He holds that a beam splitter, things all go one way or the other, but I hold they go both ways. But it gets broken up and then reunited. But absorption is always quantized. You always get a whole photon with absorption. You always get a whole photon with emission. But in between, it can get broken up and recombined and all sorts of things. And I go into this in some detail in my chapter on light.
And you're referring to your book.
To my ebook, A Model of the Physical World, which I would encourage people who have time to take a look at. And again, I definitely am interested in like feedback about it, the details.
I know I've given you lots of feedback.
Yeah, you have, Harry. You've been very helpful, Harry, and I appreciate that.
Okay, we're coming up on 2 minutes here before we're going to get cut off. Jerry, do you have any more questions or brief questions that we can answer before the next session?
Well, I have more questions involving quantum mechanics, but I won't go into that here because that isn't specifically what this is about.
Well, I think Bob's theory is really kind of Bob isn't 100% classical in his thinking. I think that's the point of what he's trying. But
I am at least a realist.
Yeah, yeah, but you're not. You're trying to, as I see it, you're trying to reconcile this classical electromagnetic ideas with the quantum ideas.
Yeah, that's right.
And the quantum turns out to be the thing that messes a lot of physics up. And so.
Yeah, you never get anything definite. You just get these probabilities and things. And I try to motivate those like off of intensities of fields.
I did have a question that when we were talking about, is string theory where this multi-universe business comes from? I find this puzzling that people could think about there being multiple universes.
I don't think originally, since Hugh Everett, he was writing in the late 1950s, and I think, maybe I'm wrong, but I think that predates string theory.
Yeah, well, I think one interpretation of the quantum mechanics of the wave function collapse, I believe, is parallel universes, which, in other words, is many worlds theory, where there's multiple or infinite possible universes, or that somehow exist everywhere. Or
only you don't have a collapse. It's just you have the different ones in each of the different parallel universes.
All right, we're going to cut off.
And even getting back to this dark matter business we have talked about, it is said, quite bizarrely, but it said that this might be dark energy or dark matter, might be just matter or forces coming in from another universe, a multiverse.
Yeah, I don't have a strong opinion about dark matter. I don't see any positive evidence for it. As far as I can see, it was postulated to help save relativity. And since my theory is not based on relativity, I don't particularly see a need.
I think it was Roger Anderson who offered to put it up on on YouTube or something.
Yeah,
that was Roger.
Roger wanted the recording, and and I'm sort of haven't been doing it because it's kind of, I'm not sure what's going to happen here.
Yeah, I mean, I really don't care one way or the other. I think at some point, if there's enough interest, maybe getting something that really looks good and putting that on the internet would have something to be said for it.
Right. Okay. Just on the conversation part, I've never really looked into this business of multiple universes. You know, to me, that's always seemed like just an extra confusion factor. So that's I'm kind of glad that kind of came up. Maybe we should talk about that a little.
I've actually written extensively about it: parallel universes, higher dimensions, and multiverse. Just simply to refute it.
Yeah, well, then you can give us a presentation about it next Sunday, then, right?
Sure.
Yeah, I find it confusing. I thought it came out of string theory. That's why I asked Bob about that.
No, as far as I know, it was Hugh Everett who came up with it. And I really think that precedes string theory.
Yeah, but is that the only version of it? Is his version just one?
No,
version?
I wouldn't want to say that either. There's been a lot of work, and they don't all say the same thing. So no.
Yeah.
Is the floor open to more questions?
Sure.
Sure.
If each particle is in its own three-dimensional subspace that you mentioned, when you write the position coordinates, I guess for each particle is going to have their own position coordinates in its own subspace.
Right.
How do you get two particles close to each other as shown in your subsequent illustrations?
Okay.
How would that even be known?
Hold on. I'm not sure the particles are in different subspace. It's the thin shells that are.
Yeah, the thin shells are. The particles just make this work. The easiest move I could make was to make the particles be four-dimensional. So it's like they go through the whole series of shells. That's how you have effects from each of them on it. But it only emits in its own particular subspace. Just to make it work. It sounds a little odd, but that's the only move I've been able to make to make things work.
Okay, so to make this clear, the particles aren't in any four-dimensional subspaces. They're all in the same three-dimensional space. It's the fields that are in different.
It's the fields that are in the parallel subspaces, yes.
Okay, all right.
Well, then how would any particular particle impinge or come close to any of these fields?
By impinging through the whole series. Because it's four-dimensional.
What is the? Oh, well, I didn't see any fourth dimension in your presentation. So
there may have been something lacking, and thank you for pointing that out if I didn't make that part clear.
Well, by four-dimensional, do you mean like three with the addition of time, or like
No, not
spatial?
with the addition of time. No, a fourth spatial dimension.
Okay. How is that different?
Well, Vlad would love that.
Yeah, well, then I'm not sure we want to get into the question of whether it's talking about Riemann spaces or not.
Yeah, well, here's what I've just to simplify things, I've kept everything Euclidean, and I maybe it's not Euclidean, but to simplify things, I've just been keeping everything Euclidean.
So to write down a particle position, then there are four parameters: X, Y, Z, and a fourth one.
Yeah, I find you're best off here with spherical polar coordinates. So you have a radius away from an object. And actually in my ebook, I do give some equations for equipotential surfaces. You might want to look at that. I didn't have a slide for that. But to do those, you have to use like a bipolar coordinates, spherical bipolar coordinates, where you have like one axis on one particle and one center on one particle and the other on another particle. And you can generalize from bipolar to multipolar coordinates.
Now, I did want to go back to the things that I was talking about towards the end of the previous session, and that was that you're interested in quantum mechanics and the issues in quantum mechanics. And as I understand it, this ideas that you're working on is an attempt to sort of make quantum mechanics make sense.
Yeah, make it realist, so things really exist.
Right.
Yeah.
Okay, now, before we proceed, can you explain a little bit by what you mean by realist?
Okay, that something exists, literally exists. And again, you have literally exists as experiences and literally exists apart from experiences. And my basics there, of course, are these ideal liquids. And I've given that several properties of them. I don't know if I can do much better than say that I take their existence literally. In philosophy, they talk about it as an ontological commitment. Ontology is the study of existence.
All right, you're fading out a little bit. You faded out a little bit there. Could you go over that?
Okay.
A lot of people, you explain what you mean by ontology.
Ontology, okay, it's a philosophical term, but it means the study of the way in which things exist. And so you have to have a primitive, and my primitive is the idea, at least for the physical world, which again, for me, is apart from the world of experiences, but my primitives are ideal liquids.
So you think something exists indeed, but you don't equate the noumenal with the phenomenal. I think you said that.
No, I'm a dualist. Although I think they're both spatial. It's just their geometries are different. There's the geometry of visual experiences, and there's the physical geometry of physical entities, and they're different geometries.
How would you describe the nominal world? I mean, as far as phenomenal, like is nominal, because I think because Kant was admittedly a mystic, or he tried to secularize religion and such. And
Kant's real mixed business. He uses words in different ways and all sorts of things. He
did have some good ideas, though. The nominal world, I don't know if that meant like a spiritual world, for instance.
Depending on how you use the word spirit, and if you use it in a loose enough sense, maybe. It's basically consciousness.
Okay. I actually think that consciousness, and this is way out there, and many of you probably won't agree, that consciousness exists in a different realm than the physical. I mean,
I tend to agree. As I was saying, I'm a dualist, but there's a causal connection, at least one way, from the neural correlates of consciousness in our brains into like what I call phenomenal space. And I think each person has their own phenomenal space. It's a private space.
I would say the processes of the brain, for instance, are highly physical, though
definitely.
Consciousness, you can't explain consciousness.
Well, you can try. It's hard to make much progress. There's the mind-body problem that I don't think anyone has solved. There's some causal
then you wouldn't be merely a dualist. because you would consider a multiplicity of phenomena depending on who the observer is.
Yeah, yeah.
Hmm.
Well, but so you're right in a sense. There are dualists in terms of types of things existing, physical and phenomenal. And I do think each person has their own phenomenal space. Beyond that, it's hard to say all that much constructive, except that there's some sort of a causal connection in the brain that I don't think anyone really understands. It's known as the mind-body problem in philosophy.
Well, in consciousness involves complexity of the electromagnetic field. This is shown by neuroscience work because, for example, when neural activity in the central switchboard of the brain, which is called the thalamus, becomes synchronized, people go blank. They go unconscious.
Yeah, but that doesn't prove that it's the same thing. It just proves that, okay, that you can mess up the causal connection. I don't know. I've done some work with some neuroscientists. I co-published a book with John Smithies, who is also a spatial substance dualist. I just had another book come out with Springer that I co-edited with someone from the University of Miami. So I've done some work, but one thing that strikes me is not everyone says the same thing, even among neuroscientists. So, I mean, getting anything definite on this subject, I find is difficult.
Well, we don't have to continue consciousness if no one's interested. I mean, that's just a thought. It interests me, but we can return to the physical.
I mean, you have a certain amount of time. You can use it. I'm happy to talk about anything people want to talk about.
Well, in your illustrations, you say there are forces between charged particles, either repulsion or attraction, correct?
From the thin shell, so it's an indirect process. I don't believe in action at a distance.
Okay.
So the shell is immediately adjacent with the particle.
So have you attempted to rewrite Newton's force equations?
The only move that I've tried there is where you do a summation on forces. I do the summation at the end, so I don't think there's one field with contributions from each particle, but instead, with each, it just makes a contribution to its own particular field, and the summation occurs later when all of these intersect with another particle.
Well, I have a question.
As far as I can see, the two are mathematically equivalent. Just where you do the summation.
Why isn't there action at a distance, such as with objects, attracting in space?
Okay.
Why don't you believe in action at a distance?
Okay, that's
what
actually
causes the illusion of it if it doesn't exist?
Okay, that's a good question. My position on this is actually close to Descartes, who worked with a series of something like shells, so there are some similarities, but he doesn't have a parallel subspaces or anything. So he says that all action has to be immediate. Newton, as far as I can see, just doesn't make a stand. Some people associate action at a distance with Newton. As far as I can see, he says hypotheses non fungit, so he doesn't make a stand as far as I can see. And he didn't have a theory of a field, of a gravitational field. But I don't know if anyone knows a place where Newton clearly comes out for action at a distance. I'd be interested.
Well, Einstein often spoke of action at a distance as well.
But the immediate cause for Einstein is space-time curvature, and of course, with space-time curvature, something's following a trajectory in space-time, which would be right next to the curvature would be right next to the object going with its trajectory.
Well, for Einstein, the speed of establishment of the force, if you like, owing to curvature or whatever, is the speed of light. For Newton, you have an action at a distance which is, for all intents and purposes, infinite. So, in other words, the establishment of a gravitational field is infinite. It's infinitely fast. Now, what's your own view on the establishment of electric fields or gravitational fields?
Yeah, actually, I believe in gravitational waves, which I think go at the speed of light. And you don't have to believe in general relativity to believe in gravitational fields.
Yes, I agree with that. But I'm
Waves.
asking not gravitational waves, which you've described there, but say the establishment of a gravitational interaction between planets or whatever. What speed would you say that goes at? I mean, Tom van Flandern would have views and experimental bases for decrying the Einsteinian view that they're established merely at the speed of light, irrespective of what you've said about gravitational waves.
As far as I can see, because I think things propagate through the thin shells at the speed of light. So if there's any change, I would say it goes at the speed of light. But of course, it's with an emission theory, so it's the speed of light with respect to a source particle.
Many actually think that that gravity is instantaneous, unlike the propagation of light. There's a thought experiment that I often have thought of. If the sun were to just theoretically, of course, if the sun were to disappear, would that they say it takes around 8 minutes for the light to keep on coming before you don't see it anymore. But would the Earth leave its gravitation? Would the Earth leave its orbit and go off in its own direction because gravity isn't there anymore? Or would it take 8 minutes around before the Earth departed from the orbit?
That's a good question. Or you might also think of the case like a particle and its antiparticle annihilate each other. What happens to their fields? The best move I think I can make there is that they just disappear going outwards at the speed of light. But again, you can try different variations, but what I've been working at is to not believe in action at a distance, but to hold that things within the thin shells move at the speed of light.
So just following that up a little more, there is a light aberration in that the light that we actually get from the sun now on Earth is actually that which was emitted from the position where the sun was 8.3 minutes ago. That's correct. But there isn't a gravitational aberration. If it weren't effectively instantaneous, well, then the system would be unstable and the planets would spiral out. You'd get actually a couple, on the force of the planets being attracted by the sun, and they would spiral out.
Yeah, okay. Well, maybe 2 points. One is on aberration. Actually, there's a nice emission theory account of aberration in terms of like raindrops, which works best for the ballistic version of it. But then as you move with respect to the raindrops, it's as if they shift their angle, but they really aren't shifting. On the rest of what you say with respect to gravity, you're talking about something I actually don't know about, and it's hard for me to have a strong opinion on it. But you do want to have a model be consistent with known results. So if what you say is right, then you'd have to come up with an account.
It would seem to, like, as far as the thought experiment of the sun disappearing, since gravity is constantly there and objects just don't disappear, you can't really gauge, if it's instantaneous or if gravity travels, so to speak, because there's no way to test that.
Yeah, except they do test for gravitational waves. My understanding is with positive accounts, positive results, and whether anyone's questioned that, I don't know.
So
I would say that gravitational waves are perturbations in the ether, if you like, which are caused by variations in gravity. And electromagnetic waves are perturbation in the ether, which are caused by electromagnetic phenomena. And both of these go at a value which is a speed, which is determined by the properties of the ether. Yeah, that seems logical. But you can find out the establishment now. Maybe not gravitational field so easily, but say electric fields. You can do some measurements about how soon after the establishment of an electrostatic field the effects of attraction or repulsion are experienced, say, on another object which is remote from it. And some of the experiments seem to indicate that, well, I don't like an infinity. That's like a singularity, but the speed is maybe 10 to the power of 20 times the speed of light or something. It's a very, very large.
How well accepted is that result? Because
yeah, it's hard to answer that. I mean, it's a good question. You would have to concede that it isn't accepted because the mainstream academic established views, which are held widely, are that these forces travel at the speed of light in accordance with
which I tend to be sympathetic with. Why don't I say something about ether, which I've really tried to be neutral on. Some people have tried to describe my theory as being an ether theory, and some haven't. I definitely believe in fields. What I've always tell people is if someone wants to call my theory an ether theory, that it doesn't bother me. And of course, when the thin shells are initially formed, you are pulling something out of something else, and that starts to sound more like an ether. So I'm not really necessarily adverse to ether theories. It's just I think you use the term and it may be misleading to some people.
I personally heard many different conceptions of the ether, and many of them, I mean, there are a lot of differences, and I mean, I don't know if it makes sense to call them all the ether because they're so different.
Right.
I mean, they're similar, though there's many of them.
Oh, definitely. Yeah, you get lots of variations on ether theories. Well, I find in this whole business is no two people seem to say the exact same thing, which is for better or worse. I don't know. I'd like to see more collaborative work among people if they have enough in common to do it. As I was saying, I'd welcome that.
Actually, if you want to.
What's that?
We can email afterwards if you want.
Oh, definitely. I find there's not that much interest, so I definitely would welcome it.
I think I brought that up yesterday, and that the word medium and ether are both kind of get the same kind of reaction. It's different people have different ideas about what the words mean.
What is the difference between the medium and perfect liquid? Your opinion?
Between the ether and what?
Perfect.
I'm asking Harry right now. He can see this something in common, but what is the difference between the medium, in your opinion, and perfect liquid we heard today about?
Okay, well, the medium for me will be the thin shells. And I do in my ebook, I didn't talk about it today, but I do give a model of light, how light, like a spread out particle, I call it a wave particle, is transferred from one shell to the adjacent one and so on at the speed of light. So that acts like a medium, the whole series of thin shells.
I sort of picture thin shells as just sort of a slight barrier or something that's very limited. I didn't realize that it was continuous or extensive.
Yeah, I think of them as going out indefinitely into space.
Oh, okay.
Right. But not infinite, because you state that space is.
Yeah, I think it works better with a finite model.
Okay, yeah, I understand why you say that.
Can I
So,
ask a couple questions?
okay, go ahead.
Sure.
Okay, I am talking about the real world intergalactic plasma. I'm totally agree with you, your first comment, that this model trying to put classical notions, classical fields, and all this stuff into the quantum physics. You know my opinion about the border between both these sciences. They are totally different because one particle or ensemble of particles, it's totally different story. And very good example, it's double slit experiment when you have two properties at once. You have your photons, you have no interference. You have your interference, forget about photons. But what is important? Let me ask you the question. Liquid. What does it mean liquid? If intergalactic plasma has such a concentration, proton, one electron per 4 cubic meter. What kind of liquid you are talking about?
I'm talking about an ideal
The
liquid.
distance between them, 4 meters at least.
Yeah, I'm talking about an ideal liquid. So it's an ideal concept, and it's definitely not the same thing as any physical liquids like water or anything like that. It just has some of the properties in common.
That's why I named my ether as a medium, because the distance between particles so far away that you cannot talk maybe about air, even air too dense about against this medium. But liquid, classical notions. It's ensemble of particles and so on and so on. Please find some other definition for your medium or liquid. I don't know, because liquid, it's a classical notion.
Yeah, whether there's a better word, I don't know. I just take some properties from the classical concept, but it's definitely not the same thing as a physical liquid. You need
Absolutely
to
wrong.
something.
Absolutely wrong. You cannot take your classical notions and to put in a quantum physics. This is my main point.
Yeah,
The
one
next
thing on
point.
quantum is I think they should look for consistency, if nothing else. And they get too much subjectivity into the quantum theory and any number of things. And I even know
Next
some
question.
experiments to go
I'm sorry.
against, like wave particle duality. You can actually show wave properties and particle properties at the same time with the same experiment. Going against the Heisenberg uncertainty principle, you can actually show momentum and position with a more precision than Planck's constant. I know of at least one experiment doing that. Or like Niels Bohr on distinguishability and indistinguishability. Uh, you can actually, again, you can have both with the same experiment, the Afshar experiment, for example. To me, they get a principle and it's there historically, and they do interpret things no matter how to hang on to their principle. They want to refutation. There are good experimental results that go against a lot of those principles.
Okay, let me ask you the second question. I'm so sorry because I didn't understand too much about what you talk about. There is another classical notion, field. What do you mean field? You cannot transfer electromagnetic field from Maxwell equations to quantum physics, to quantum object. What do you mean about field? What do you mean by this word?
Okay, my most basic field is the electric field. And I give a model of the electric field with my thin shell.
Electric field belongs to Maxwell equations, and it is classical notion. How you can transfer your electrical field into quantum physics? I have no clue.
Yeah. Okay. As I was saying, I'm actually not a big fan, for example, of the Copenhagen interpretation of quantum mechanics. And
not expert in quantum
I don't like
physics at all.
probabilities as being basic either. So to me, you try to give explanations for the results. And even whether you want to call it a quantum theory, I don't know.
1 second. What are the results of your model? Experimental results we can observe, please.
Okay.
At least one experiment.
Okay, the most basic one is just the Coulomb force. Inverse square law for
it's a property of classical physics.
Yeah.
There is no correlation between what you talk about right now and classical physics. I'm sorry. What
Okay.
is your proof of your model? At least one.
Okay, it's not, you don't have proofs. You'd never have proofs in science. Okay, something that confirms it. It does, I think, give a good account for the Coulomb force. That would be one. So you just want at least consistency with known results. Beyond that, as I was saying, they did try this experiment at University of Maryland, Baltimore County. And I do think there's some interesting ones, like with the primitive reference frames, like rotational reference frames, which, as far as I can see, NASA ought to be more interested in doing.
Please answer the questions. You're talking about something around, but I have a very simple questions. Field, liquid, and all the other stuff, electric field, you took from classical physics and you put into your model. What is the reason? What is the confirmation that it's possible, it's feasible to do? Because it's a two different science. I don't know from philosophical point of view for you. Maybe it is the same. But for me, as a physicist, I am a physicist. I want to know the difference between quantum physics and classical physics. That's why I'm asking principle questions to you. And you're a philosopher. You should think about some principles of the world, not about some details.
Yeah, okay. And I'm sure you know more physics than I do. I know a number of
I have no
physicists,
doubts
but
about it. I'm sorry.
yeah, no. I'll grant you probably know more physics than I do.
I would personally say that okay, I'm unsure of exactly what all classical physics involves, and I have many questions about quantum mechanics. However, if they're both accurate theories, they should coalesce somehow. There should be a way to unite them. Though I have doubts about, well, especially general relativity, for instance, trying to combine that with quantum mechanics. Though, if classical mechanics, classical physics is an accurate theory, and quantum is as well, why couldn't they unite? I mean, they're part of the same reality, you know.
Probably there's a mistake somewhere. That's my thesis.
Yeah.
and
Physics right now in crisis too, guys. Don't touch it. Because if we will have a mixture between classical physics and quantum physics, it's forget about any understanding. That's it, simple like this. If you can see some, I don't know, some reports about some famous, one of them, Sabina, she started the crisis in quantum physics too. Man, we are right now in crisis of the whole physics. And if we will have a mixture of them, we will never find out what is right, what is wrong.
Yeah.
That's why,
Right,
please, nobody knows quantum physics right now. Quantum physics right now in crisis. There is no space, there is no wavelength. You cannot use Schrödinger equation and all this stuff. That's why you put yourself in a mess of quantum physics. And you're trying to put some classical notions into the mess of quantum physics. It doesn't work this way. I'm sorry.
Well, Vladimir, would you say you disagree with quantum mechanics?
I don't know quantum mechanics at all. I agree with quantum objects. They exist, no doubts about, because classical physics, as you know, emergent phenomena based on quantum objects, but ensemble of quantum objects. That's why I do believe in the existence of quantum objects like photon, electron, proton, and all this stuff. No doubts about. But about the property of them, I have no clue. And for me, from classical point, I will take statistical analysis of these quantum objects, and I will find temperature, the pressure, and all these parameters without knowledge about the properties of each quantum object. This is the point. Because quantum objects, they have only four momenta only, means power, momentum and energy. That's it, what they have. For me, for classical physics, we don't need all these wavelengths and all this stuff. We don't need it. And what is important? For each electron and proton to have wavelengths, to have the sphere around and all this stuff, it's our imaginations. We have no clue. Because as you know, in classical physics, even oh my God, the space and time, it's a classical notions. You cannot introduce to quantum physics all these parameters, radius, time, and all this stuff. You know, this is the main point. If there is no medium, as I told many times, there is nothing. There is no space. There is no time. There is nothing. What we talking today about? If there is nothing for quantum physics, sorry for my
I thought time and space did exist in quantum physics.
no, no. This is the main point. You cannot use
So,
this.
so that is that one of the main factors of why that there's no point possibility of unification.
Never. As I told you, you cannot talk about the physics of ensemble of objects and try to put it into each object, into each object.
If you haven't studied much of quantum mechanics, how to know there isn't possibly a way to find a way to unify them?
I'm so sorry, I misunderstood your question. Please repeat it.
Well, I mean, you said you aren't that familiar with quantum mechanics. I mean, maybe there's possibly a way that you're unfamiliar with. I mean, I have many questions about it myself.
I don't know quantum mechanics. I passed university course and I don't agree with it right now. Forget it. The second very important, I'm not expert in this business. What is I am against right now? Don't transfer your notions from classical physics to quantum physics. That's it. I'm not against quantum physics. Develop a new theory without time, without space, without all these classical notions. By the way, my friend, a few times already reference to him, Felix Lev. I was graduating from the same school at the same time, and he already developed a totally new theory of quantum mechanics. And which one? Based on operators only. There is no space, no times. There is a mathematics. There are some operators, and he developed a new quantum mechanics. If you wanna, I can give you the reference to his papers. Maybe as an expert in quantum physics, you will see the difference between his approach and what we have right now. What we have right now, I mean, basic of quantum physics, it's absolutely wrong. His model maybe it's much better, but I'm not expert. I'm not trying to judge any theory I have no clue about. That's why if you're very interested, I will give you these references, no problem, because no space, no time, no wavelengths, nothing for quantum physics, we can use it. We must overcome all this, transferring. By the way, even this perfect fluid, Harry is absolutely right. At least 300, 400 years, the beginning of electricity was based on the same idea. What the difference is? They knew nothing about electrons and protons, and now we came back to the same story. 300 years old. I'm sorry.
Well,
All right, we're about ready to end
Oh.
here, so make it brief.
Oh, well, I would say that what I've heard of quantum mechanics, that time and space are inherent, like such as the uncertainty principle with you can't tell the position and momentum of a particle at the same time. That involves time. That involves a space that they exist in. Even though I don't see how that adds up. I mean, if you know its position, why wouldn't you know its momentum? They're connected. But that's just a thought.
No, it's wrong too, because momentum, they have it, but space doesn't exist. Space doesn't exist. What are you talking about? All the particles, they have only
may
four
deny
momentum.
it, but they have to use it.
They
I
have
know, but
Hilbert's.
it's wrong. This is my point.
They
It's
have
wrong.
something. They have something called Hilbert space.
Right, that's an abstract space.
It's
Abstract space you can use for quantum physics, but please don't touch classical physics. It's forget about it, because
Well,
it's a totally different story. That's why, any approach, it should be some special space, special mathematics, everything special. No correlation between what we have in classical physics and in quantum physics.
What all does classical physics involve? Is that primarily Newton or others in his day?
The beginning from Newton, of course. And I gave you the history history of classical physics yesterday. By the way, I have some proposal next, session when we will start it to talk about my model.
Relative to each other.
All right, we started talking off about relativity. Okay, so now I got the
we don't need
recording
it
going.
right now.
Yeah.
Let me finish my sentence. I started the previous session. Guys, I do like very much our discussion today. So good discussion, professional, good questions. Instead of my presentation yesterday, I would like to ask Harry next time to discuss my model only, step by step, and I will try to answer all your questions. You ask these questions, and I'm ready to talk about these questions inside of my model. Harry, please make arrangements the same as you done today. I love it. I love what we have right now, man. It's
Okay,
a very good, it's much more productive, much more efficient than any official presentations what we have on Saturdays. I'm very sorry.
well,
I'm
the
not blaming
problem,
them, but I do like what we have today.
I think one of the issues with the Saturday is it's very difficult. The StreamYard doesn't really work that good to cause an interactive discussion. When one person was talking, I couldn't hear what he was saying because my computer was spinning its wheels and I couldn't hear what was going on. StreamYard just doesn't work for this type of discussion. It's just not capable of doing it. Anyway.
I think for the CNPS,
what we have right now.
For the CNPS as an organization, it's probably most useful to have both forums. We have a sort of a fairly formal presentation on the Saturday, and then we have this very comprehensive interactive session. It's probably useful to have both, actually.
You're absolutely right. It's exactly my opinion. Yesterday I had presentation, and today I want to discuss with experts, with specialists in this area, step by step, point by point. This is a very good example today. Robert, it's a very good you came to our meetings and you refreshed even our position about our meetings, what we're gonna do with it. Oh my goodness. I'm so happy to be part of this today meeting.
Yeah, that's good. You're good, Vladimir. Actually, I might agree with you on something else. I think maybe like you were talking about having another conference or something. I think you need a lot of pre-planning for something like that, but I'd be amenable to going to something like that if it would be productive.
Okay, thank you so much. But please, next time in a week, Harry, please, I would like to do my presentation about model only, without all this extra history or physics or what is the experimental results. I explain it does matter. For me, it does matter that you will understand my model step by step. I will stop, read it, what you mean. You will ask me, I will answer. Oh my God. It will be the most important for me to understand what are the questions about my model.
Okay, so you're proposing that for Sunday, next Sunday?
Next Sunday, I propose to do the same. Robert done great job. I want to do the same job with you guys, and let's have some discussion, as I told you, point by point. Not when I read, and everybody already forgot what I started with. And today, it's a very good question. We ask very good principal questions. What does it mean? What does it mean? What is going on? How you can go this way, and so on and so on. No doubt that today this string theory arranged we talked about today. We started about it, talk to Ebook because his model, he is close to string theory. But string theory, it's a mathematics of multi-dimensional objects and all this stuff. The same story in here. This shell around electron and proton, I have no clue what does it mean. Because space, it's too small. Time, I don't know, and so on and so on. This is only our imaginations, like, string, like these shells I didn't see any difference between them. I mean, principal difference, not in shape or in something. And to try to put classical physics inside of quantum physics, this is against, guys. We cannot. Double slit experiment shows you want to see one photon, you will not see interference. You don't touch photons ensemble, you have your interference. Simple like this. And Richard Feynman, he told, I cited him yesterday, he told it's impossible to explain, impossible, because people they are trying from one basis to explain these two different experiments. Instead of quantum physics, photons, you can see it. Classical physics, leave it alone, separate. Even Richard Feynman, he didn't understand. It was maybe too early for him. Only now we can tell what is the difference, why this double slit behaves like it behaves, not like our imaginations.
Well, Vladimir, would you say you've heard of the wave function collapse?
Wave function doesn't exist. I don't know what do you mean, wave function.
They say with the double slit experiment that well, it's either light or electrons or protons or something. They fire through, and then on the wall there's the interference pattern, and they wanted to figure out how. And so they put a which way detector, they called them, right there at the edge of the slits to determine what was happening. And with that observation of the which way detector, it wasn't even human observation, but it created the two slits on the wall. The interference pattern totally disappeared, and the two slits on the wall surfaced, and they thought it was observation.
No, Jerry, it's not our eyes. You can see, you cannot see. No, man. It's you have your detector. I'm highly skeptical
of the experiment myself. I'd love to see it done someday. I sort of suspect it was fabricated at some level.
Let me tell you, it's not our eyes, a detector. If you will, on a slit, to put a detector, you will see that photon passed it. Immediately, you will lose your interference. It is not eyes. It's a detection of each photon.
They did say that somehow it did cause it to revert from an interference pattern to just the two slits, just a straight pattern.
If you have each particle going through, you will have only slits. If you don't touch it, you have ensemble, not disturbed, nothing. You have your interference pattern. It's a two different characteristics of the light. Photon, quantum object, ensemble of photons, light. Interference of light, not of photons.
You would say that each pattern is possible, though. The two lines and then also the interference pattern at different times. If so, what is the cause? What is the difference?
Repeat one more time. If you're not touching this light, you're not touching. You're doing nothing before you will see this interference pattern. It is light. It's ensemble of photons running to your slits. Ensemble. If you put your detector in front of your slit and you're looking for each photon going through, you disturbed all this ensemble. Ensemble disturbed, wavelengths disappeared, no interference pattern. Simple like this. Detector, not our eyes. You can block from your eyes from everything. Leave only photo detector and wall, and you will see the difference immediately.
I don't really understand the mechanics of it, but I don't understand why which way detector would cause it to revert to two lines instead of an interference pattern. Though that's just, I don't understand how that could happen. I don't see how it could happen in any way. I think it's maybe fabricated. Personally, I don't know.
Even Richard Feynman didn't understand. That's why you are not so unique, man. Nobody could understand it before.
Well, as far as I can tell, the Copenhagen interpretation, the many worlds theory, and others were meant to try to explain the wave function collapse.
And even he didn't explain based on this Copenhagen school. What are you trying to do? You want to be smarter than Feynman? I doubt. I'm sorry. I envy him.
I mean, on the shoulders of giants, you can see further. I mean, I'm not that familiar with Feynman, but I'm sure there are certain things that I might find questionable nowadays because
he was
I doubt he was a super genius who knew everything. You know.
Yeah, one thing actually I agree with Feynman on is like light taking all possible paths. But for me, it's all physically possible paths, not all like mathematically possible ones. And I would explain the double slit experiment in terms of like a light getting broken up and then recombined. And you'd have to really get into the details about how detectors work.
You told immediately right now, you will broke the system of your spheres or whatever shells, That's it. It's exactly the point. If you are not touching it, you have your light. If you will touch it, you damage, you disturb this,
Absolutely. You're interfering with the system. I agree with you there completely.
Well,
but system, it's exactly classical physics. It's not
I'm beginning to see now kind of why you took your approach with womb, but I don't really think that people really understand that. I think people believe, that it makes sense to take quantum physics and classical physics and general relativity and special relativity and mash them together, and then you get a cosmological theory that explains the universe. But they don't question any of the foundations that they're using when they put all this together.
You're absolutely right, Harry. Absolutely right. That's why we have crisis right now in the whole physics, not in classical, not in quantum, because we've done this mixture and we opened our hands. Oh, what's going on? We've done this damage to the physics. For the last 50 years, there is no development of physics at all. On the contrary, physics right now dying because of these mixtures, because of this mixture of these notions and so on and so on. I'm very sorry. That's why, please, let's talk about my model based on my approach. Quantum physics, leave it. By the way, we have a temperature in our room. We have no idea what is in our room. Oxygen, hydrogen, whatever, nitrogen, and so on and so on. But what is important? Maxwell, 150 over 200 years, close to 200 years, calculated statistics of these particles, and he found the expression for temperature. You see the difference. Quantum objects, molecules, they exist. Statistics of them exist. Temperature we measure exists, but it's a classical notion, classical parameter we can measure. Do we need to know something about this kinetic energy of these molecules? No, there is some ensemble of them. Which one? Let's make some statistical analysis of this ensemble. Very simple. It's very simple. Look, the classical physics doesn't need peculiar properties of each quantum object. Molecule, I have no clue what does it mean, but I can measure the temperature. And the same story with my medium. I don't know what does it mean, proton and electron. I know they exist. The distance between them, at least 4 meters. Man, so far away. We are not talking about even air. In air, our molecules much closer to each other. That's why, you will be liquid, perfect liquid. It's absolutely wrong.
Well, I'm guessing what you call a quantum object are particles such as protons and electrons, but they compose the universe at large. So isn't everything quantum object?
All quantum objects, you can cut this quantum. There are some micro objects. Quantum, not quantum, it's up to you. For me, there are molecules around me. There are around you. We can hear each other because there is some vibrations of these molecules and so on and so on. For me, I put quantum objects, quantum physics based on their definition. For me, there are some micro objects, and I'm looking for statistics of these micro objects to find emergent phenomena like, mass, gravity. By the way, gravity, space, time, all of them emergent phenomena. They exist only in classical physics. You must have an ensemble of something. That's why I put this ensemble of the first particles generated by universe. And when at 10 to the minus 18 seconds, you can have the first ensemble of particles and you can start talking about the medium. Oh, guys, at this moment, at least all the representative of the medium exist. And then, only then, you can introduce space, time, gravity, and so on and so on. Einstein, by the way, talked about them. I cited his words. He claimed it, and he didn't know how to prove it. I proved it. He told, space-time gravity does not exist without matter. What does it mean in his words, matter? In my case, it's medium of the world, matter. Yes, is absolutely right. He was absolutely right. It was a very good claim of him, but nobody heard it. Nobody looked at this claim. Space-time gravity does not exist without matter. In one sentence, he told the value of general relativity. And when we have empty space, empty something, I don't know what does it mean. There is no space.
He said it didn't exist without ether. He didn't say it didn't exist without matter. He specifically said ether.
Ether, it's exactly ether, but I have a special ether I named it medium because I don't want to use some well-known, notions, ether, perfect medium, and all perfect fluid. By the way, in gravitational equations, there is perfect fluid. All the equations,
But you just now
Friedman, he
named it
calculated
matter.
all his equations based on a perfect fluid. Do you know this? There is no empty space, or there is an empty space. There is a vacuum or not a vacuum. In 1916, it was no vacuum. In 21 or 22, Friedman gave his equation with perfect fluid. He put this pressure, he put this mass density, and all this stuff. Guys, I'm very confused. General relativity, it is what? It's what? Vacuum, or it's what? Or perfect fluid? I don't know. Guys, math. We have in physics right now, math. I invite all of you guys next time, Harry, let's make arrangements. And then point by point, I will try to explain what I'm trying to tell right now, man. It's only one point. You must see the whole picture, how it works, what is base of it, how it's experimentally proved. So much new experiments, so good experiments. I'm so happy to have them and to explain them on the base of my model. This is my main enjoyment. I can see how it works. Robert, you told very good. I'm sorry. You told today very good words that it should be some confirmation of your basis. You're absolutely right, but you didn't show even one confirmation of your theory. Please, I ask you at least one experimental result that prove your approach. In my case, yesterday, I put 2 pages of confirmation of my model, one by one, one by one. This is experimental. Physics is experimental science. You must have your model, and then to confirm your model, you must have some experiments.
It certainly does help
it.
if you can run an experiment that confirms it with something new. As I said, I've tried a few times. There's nothing really new to report. I do think some things NASA should get interested in with testing like frames of reference in outer space and things. I think that could be quite interesting. And I have a few other ideas. Even if something does confirm a prediction, it doesn't prove your theory. It just shows that it's consistent with it.
I'm very sorry.
Enough, believe me, just
I cannot hear you. I'm very sorry. Please close it to your microphone.
Yeah.
Okay, it's better right now. We didn't hear anything. I'm so sorry.
Okay, well, maybe I'll repeat it then. As I was saying, I have looked for results, but I don't really have anything to report that's new. They did do that experiment in China, but as I was saying, for NASA, I think they tried some experiments in outer space looking for special reference frames like rotational reference frames. I think that could be interesting. I think this one, Jean de Clement suggested for testing the relativistic theory of magnetism. I think that could be interesting. But even if the result is in accordance with the prediction, it doesn't prove your theory. There might be another theory that's also consistent with the new result. And it's hard enough just to have your theory be consistent with known results. Believe me, I've made a strong attempt in that direction, but I haven't completely succeeded. There's a lot of room for improvement.
You didn't succeed even with one experiment that proves your theory. I ask you a personal question. Give me one experiment. Look, you're absolutely right. Let me see. The validity of any model depends how many different experiments you can explain in frames of one model. It's exactly what my model shows, that it works not only for one particular case. I can solve many problems 100 years ago, 200 years ago, 50 years ago, and so on and so on. That's why, please take a look at the record of my, presentation yesterday, and you will see it yourself. But next time, I want to talk about the model only model, one by one. I want to hear all your questions. James, Jerry, all of you guys, you have a very good questions. Please be prepared to blame my model. I would like to hear your voices and trying to explain you what I meant by each point. Please, you are very welcome, all of you, and invite all your friends because it will be very good discussion. I bet you it will be very good discussion. Robert, or you too, of course, all of you guys.
Okay.
One similarity between Robert's presentation and Vlad's model is that they both posit a fourth dimensional thing. The hypersphere in the case of Vlad, as far as I know, and these shells, which apparently exist in their own subspaces, according to Robert. Now, both of these are really high budget productions. Like the behind the scenes personnel to create a hypersphere and move it around, and also to create these shells, each in their own individual subspace. I mean, we're talking about a cast of thousands in order. This is a very high budget proposition theories. And to my mind, in both cases, this violates the concept of parsimony in science.
Okay, Ken, it's a very good question. You started already the future discussion. I'm ready to answer only this question because there are so many of them. Hypersphere World was proposed by Riemann in 1854. It is, oh my goodness, 170 years ago. That's why it's not my idea. The next very important point, why we need hypersphere. Because in 3D, our universe, we don't have initial singularity. Because if you have your expansion, show me the point where you started your expansion. And it's obvious. It is if you have no center of expansion and you have no in your universe, you must go to the next space dimension.
Oh, so you're assuming that there is expansion. And by the way, if you look up hypersphere in various physics information sources, you'll find that it does have a center.
Hypersphere has a center in a fourth dimension. This is exactly first achievement of hypersphere because there is no initial singularity. And on the contrary, even our Laniakea supercluster, all the galaxy rotating around center of this galaxy. There is no initial singularity. You cannot talk about initial singularity in our world. Let me give you a very good example. I told you about it. You have your ball, air ball. You are sitting on the surface of this ball. You blow
None
up
of this
your ball.
answers the question. None of this answers the question.
Why don't I just say one thing here? I completely agree with that principle of parsimony. Believe me, it would be simpler not to have to bring in a fourth dimension. I've just never been able to make it work without bringing it in. So you never introduce complexity for its own sake, but some things just aren't simple as you would like. I guess that's my position.
Okay, let me answer the next question. Because in my model, there is no matter in one initial singularity. All the matter created. And I would like to have this creation homogeneous in our world. You have
The
your
Big Bang Theory
hypersphere,
has nothing
and each
whatsoever to
point.
do with my
I'm
question.
very sorry, I cannot hear you.
The Big Bang Theory has
Jamie,
nothing to do with my question at all.
what's your question?
Well, you have a big budget production here. Again, you've added a fourth dimension, these hyperspheres, and same way with Robert, he's got his shells. And this is a very big, you're gonna, this is like starring Tom Cruise and the Johannesson lady, what's her name? I mean, all the big names, very high budget, very lack of parsimony. And so I would prefer work that is low budget, because if you're going to build a universe and you're going to go and try to order some hyperspheres or some shells, in the case of Robert, who is making these? Where do you buy these things? Where do you get them? What kind of a crew do you need to put together these things? One, in the case of Robert, one for every charged particle in the universe.
Yeah,
this is
they already exist, so you don't
high
have
budget project that you're talking about.
No, I mean,
This
no, the
is
answer
like
is
big budget stuff, big money.
Yeah, but
I
according to
think-
my theory, they already exist, so you don't have to create them. I think probably for Vladimir.
Exist from where? From where exists? What you
I
talking
think
about?
Robert's hypersphere shell has a good chance. I mean, I think it can recreate it in a three-dimensional surface.
You can try.
Instead.
You can try.
But instead of being in a fluid, I think it can be in a solid. I think it is very compatible with the concept of the focused spherical waves. Instead of just being a single shell, it's actually the interaction of multiple waves focused to a point in a single medium. And I think when you do that, you'll find that you'll have the same basic characteristics your shells have as far as attracting each other. And that I think the shells have to, however, have a spin in order to accomplish the polarity of charge. But the neutral particles can have the characteristics of gravitational attraction by being a sequence of spherical waves focused to a point, and that gives you the same characteristics as your shell concept. But it can be brought into a single three-dimensional world with the dynamics of action.
Yeah, that might be interesting. You could try a move like that. And if you want to send me an email, maybe I can take a look at it.
Oh, I can do that. Your emails are in the list, right? I should be able to find your name in the list.
Yeah. Robert period French at Gmail.
Okay, I'll do that, Robert.
Sure.
I think that the comment that we just got from Cornelius is very welcome, because I think what is required in these discussions is a leaving behind of what we might call an authoritarian approach. In other words, I don't think we get anywhere by telling each other, oh, you can't say this or you can't do that. This is an authoritarian approach, which I think is really, really not a good idea. So here we see, without the authoritarian approach, some kind of possible convergence of ideas between what Cornelius has just mentioned and what Robert has presented. And I think this is constructive. The authoritarian approach actually puts away people, and it also implies why the Democrats lost the elections. They're calling people deplorables. They're calling people that they just don't understand, that they just don't get it. And that kind of indirect insult of people is, I think, ineffective in scientific discussions. A more humble approach, I think, is required. Thank you.
Okay, please stop for 1 minute. Let me answer your question, because I didn't have a chance. First of all, the first point of my model, matter didn't exist from the beginning. there is no initial singularity. For you guys, it's obvious. For me, not. In my model, there was a fluctuation, very small 4D ball, four-dimensional ball. It doesn't have even space. It will have space later. If you create, then you create continuously your matter from the universe outside. How we can put all this matter inside of a small ball without infinite density? It means we will create initial singularity. No. In my model, if you started from fluctuation and you want to create all these galaxies yourself, by the way, you must grow up with this ball, four-dimensional ball. You see, there is no way. There is a totally different story. There is no matter before the beginning of our universe. There
And
was
it can't be a
none.
small ball.
Well, there's no way to know that. This is pure speculation.
Well, you
Well,
still
It's
have
not a
matter. You don't have.
scientific
The
theory
next,
that you
the next,
presented.
but what is important?
This
You
is
believe in,
Hollywood film idea. Okay, this is
if you believe in
a
initial singularity, then
presentation
there is
at all.
nothing to talk about. You're absolutely
There
right.
is no initial
Like-
singularity. How can you measure a singularity when you have no dimensions, no activity, no reference points to
Please,
measure
initial
to?
singularity
It said
belongs to
what
general
Einstein said was
relativity.
what
I am
Einstein
not
said was
fan of it.
that without the ether, there was no existence. But there has to be within that ether, there has to be activity before you can measure distance and time, and he says that. And
Okay,
it's
10 to the
you know,
minus
you can't.
43
Yeah, how
seconds
can you
they're
measure?
talking about.
You can say
Okay,
singularity,
let me
but
ask you the
singularity
question.
means nothing
Do
when
you
there's no
believe in
dimensions yet.
initial singularity or not? You personally. Do you believe in this initial singularity?
I don't worry about whether there was an initial calm or not, because like I said, like I just said, initial
This is
singularity
the
means
beginning
that
of the story. The
initial
beginning of the
singularity means that
story.
there was a point. And if you have nothing to reference to, there can't be a point.
Well, how did the initial singularity, that's one idea. However, though, in a way, Ladner's theory of the 4D nucleus sounds similar to Lemaitre's original view that eventually evolved into the Big Bang Theory. How did it get there? How did it enter existence out of nothing? The 4D nucleus. How was that there at the beginning?
How does knowing that help us understand our universe today?
Oh, what now?
It's all speculation from before that. We need to understand how things are now and how they interact now.
Absolutely. Well, I mean, it's reasonable.
Agree with Cornelius.
Here as well.
One
was it causeless?
All right. Okay. We're coming up on the end here. This is going to be the end. I think the main point that you need here is that what Vladimir is talking about is a model. He's trying to describe what's happening, and you're kind of confusing it with philosophical principles like where did it come from and this.
Why isn't it relevant though? I think it is.
Well, because you got this problem, you have to explain the redshift. So there has to be an expansion of space, but then when you have an expansion of space, it has to have a point at the beginning where it was all squished together, and so there's this.
Why?
Here we go again. What we have to do.
Now, stop, Jim, stop. I'm just saying that's their approach. If you don't like their approach, that's fine. That's what they're trying to do. Okay. All right. It doesn't make sense. I think we agree with it, but they've got this Big Bang idea because that's the best they can do with what they're working with conceptually. Okay, if you have expansion of space and you believe that space expands, then you're stuck with this Big Bang thing. You understand what I'm saying?
I know the way.
Let me tell you, in my model, there is no expansion. There is stretching. It's a totally different story.
I realize
there is no
that.
expansion. There is no red shift, blue shift. There is none.
Right. Okay. Now, but this is kind of the point. You have to. I don't think these points are really clear in your model, and you need to lay that out to be kind of where the problem is.
Let's discuss it.
Everybody believes that the universe is expanding because they tell you that's the case. And then you have to reconcile this idea that may be false with your theory.
If you show me center of expansion, I believe in expansion. Show me the center of expansion,
Well,
because the word expansion means center of expansion.
Why,
Show
why,
me.
would, why wouldn't the 4D nucleus be the center of our universe?
well, we're going to cut off here. We'll talk about this some other time.
Yeah.
This is where the problem arises from. You got to try to make it all work together, but you're starting off with some bad assumptions at the beginning.
Robert, thank you for sharing your presentation.
You're right.
Yeah, I appreciate your questions.
Yeah,
And
thank you.
if anyone wants to do an email like a discussion, I'd appreciate it. I always try to make improvements when I find ways to do so.
Well, thank you for volunteering to present. And I'd like for Jerry to present. And of course, Vladimir has offered to do it next week. So we got lots of people offering to present now. Yay.